So this first question requires you to draw a dot and cross diagram of oxygen. It tells you that it is simple molecular and it's covalent. So therefore, you don't have to work out its ionic covalent, you know it's sharing electrons, but if you did need to work it out, then oxygen obviously is a non-metal, so you've got a non-metal joined to non-metal, so that would be a covalent bond between them. So the first port of call is for you to look up in the periodic table how many electrons oxygen has, and you will see this symbol in the periodic table, and it's this bottom number that tells the number of protons and therefore in a neutral atom number of electrons. So the first thing I would do, as we discussed in the revision session, is that I would just draw out the electron configuration of one atom of oxygen, just to look at how many more electrons it needs. So you'll see that there is a space here for 2 electrons, and so when you draw the electron configuration, you know that in the shared bit, the oxygen needs an extra 2 electrons. So for covalent bonding, what they do is they take 2 from the other atom, but they also share 2 back. So always fill in the bond first, and then you can fill in the rest. So let's just fill in the inner electrons. And then let's count up how many electrons are in the bond. So we've got 1, 2, 3, 4 electrons in the bond. So therefore, to fill it to 8 in the outer shell, we need an extra 4 electrons. So we have 4 more electrons there, and then we also need 4 more electrons here. So that would be the dot and cross diagram of a molecule of oxygen. Moving on. It says, diamond and carbon dioxide are both covalent substances. Draw a dot and cross diagram to show the covalent bonding in a molecule of carbon dioxide. So again, we're going to start off with the symbols. So if you look them up in the periodic table, you see carbon is 6 and 12, and oxygen, as above, is 8 and 16. So it's these numbers at the bottom we need for number of electrons in a neutral atom. So we'll draw carbon out first. That has 1, 2, 3, 4, 5, 6 electrons, and oxygen has 8. 1, 2, 3, 4, 5, 6, 7, 8. So carbon needs 4 more electrons. It's got space here and here for 4 more, and oxygen needs 2 more. So the first thing to do here is to draw carbon dioxide out and put carbon in the middle. It says draw the outer electrons only here, so that's what I'm going to do. I won't draw the inner electrons just to save space and save confusion. So we're going to draw carbon and the 2 oxygens either side, draw the overlaps, and then we've got to work out how many electrons go in those overlaps, go in those bonds. So you'll notice that carbon needs 4 more electrons. It's got 2 bonds in order to get those 4 electrons, so it's going to get 2 of the electrons in one bond and 2 of the electrons in the other bond. Remember, it always has to share the same number back, so it's also going to have 2 electrons of its own in there. So now we're going to count up the electrons. So how many electrons are in carbon's outer shell now? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. So carbon is now happy. It's got a full outer shell. Oxygen, however, has 1, 2, 3, 4. So it needs 4 more. And this oxygen over here has 1, 2, 3, 4. So it needs 4 more as well. And that is carbon dioxide. So next question, it says, diamond has a very high melting point. Explain why the melting point of diamond is very high. So whenever you're talking about melting points, you have to talk about what you are breaking in order to melt it. And so we've got to look at the substance. Now, diamond is one of our examples of a giant covalent substance. Giant covalent, and what that means is that all of the atoms are joined together by lots of covalent bonds. So for diamond you have 1 carbon atom, and that's going to be joined to 4 other carbon atoms, each joined to 4 others, and so on, in a huge web of covalent bonds. So for diamond to melt, you have to break those covalent bonds, and so the answer here is that there are many strong covalent bonds to break, which requires a lot of energy. Okay. Okay, moving on. So here it says, this is a 6-mark question here. So magnesium has an electron configuration of 2, 8, 2. So what that means is there is 2 electrons in the first shell, 8 in the next shell, and 2 in the next shell. And oxygen has an electron configuration of 2, 6, 2 in the first shell, and 6 in the second shell. Explain in terms of their electron configurations how magnesium and oxygen atoms react to form the ionic compound magnesium oxide MgO, and include a description of the structure of solid magnesium oxide. So this is a metal, magnesium, with a non-metal, oxygen, and so this is an ionic crystal structure, so an ionic structure. So you've got magnesium ions and oxygen ions. So this question is relying on you to explain how those ions are formed. Now, if you look at the electron configurations, you'll see that the outer shell of magnesium has 2 electrons in, and so that could either gain 6 or lose 2 electrons to fill it or empty it. And so what that will do is lose those 2 electrons, and you'll see that oxygen has 6 electrons in its outer shell, so that needs 2 more electrons in order to fill it. So the first point here is that the magnesium will lose 2 electrons to form a 2+ ion. Oxygen will gain 2 electrons to form a 2- ion. So the losing of electrons forms positive ions because magnesium will have, to begin with, 12 protons and 12 electrons, and if it's losing these 2 electrons, then that will turn into 10 electrons. So protons are positive, electrons are negative. If you've got more positive protons than negative electrons, so it's going to be positive overall. For the oxygen, that has 8 protons, and 8 electrons to start with, but it gains 2 electrons, so that goes to 10 electrons, so that now has more electrons than protons, so it's negative overall. So once those electrons have been transferred, now you have a positive ion and a negative ion, and so the ionic bond is the strong attraction between these oppositely charged ions. So if you have a negative thing and a positive thing, they'll be attracted towards each other very strongly. And that will probably be your 6 marks, to be honest. So the 6 marks here will be for the idea that the magnesium loses electrons and what charge it'll have, the idea the oxygen gains electrons and what charge it'll have, and then this description of what an ionic bond is. And the reason why it has a very high melting point is because it's these ionic bonds you will be breaking in order to melt it. Okay, final few questions on this one. So question 4, explain why chlorine has a low boiling point. So, like with the diamond question, we've got to think about what chlorine is, what crystal structure it is. So chlorine is a non-metal, and chlorine Cl2, so non-metal joined to a non-metal, so therefore it is molecular. So this means that you've got a covalent bond between the atoms, but that isn't what you break when you melt it. What you break when you melt chlorine or boil chlorine is the intermolecular forces between the individual molecules. Because if we were to break these bonds here and here, then you just have chlorine atoms floating around, not chlorine molecules, which is what chlorine is. So, to say why it has a low boiling point is because there are weak forces between molecules which require little energy to break. So you can use the word molecules here because these chlorine molecules are indeed molecules. You can only use the word molecules if you're talking about a molecular crystal structure. And if you're talking about molecules, then you'll be talking about forces being broken, not bonds. That is really important. If I put there are weak bonds between the molecules here, then I would have not got any marks at all. Next question. Tetrachloromethane is a simple molecular covalent compound. The formula of its molecule is CCl4, 4 electrons in carbon and 7 electrons chlorine. Draw a dot and cross diagram of CCl4 and outer shell electrons only. So, Carbon has 4 electrons, so therefore it needs 4 more in order to fill its outer shell. Chlorine has 7 electrons, so it needs 1 more. So we're going to draw carbon with 4 chlorines around the outside. Really important when you draw this that you don't mistakenly or accidentally overlap any of the chlorine with each other. Okay, so make sure there's just these 4 overlaps and no other overlaps there. So the carbon needs 4 more electrons. It has 4 bonds to get them from, so it takes an electron from each of the chlorines and then it shares 1 back again. So it'd be like this. And you'll notice that carbon now has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. So we just need to complete the chlorine. So this top one has 2, so it needs another 6. This one to the right has 2, so it needs another 6. This one at the bottom has 2, so it also needs another 6. And this chlorine on the left has 2, so it also needs another 6. So that is what tetrachloromethane looks like. And this last question, fluorine has electron configuration of 2,7. Draw the dot and cross diagram of a molecule of fluorine, F2. Okay, so again, this is a covalent compound. It's molecular, but it has a covalent bond between the fluorine atoms. So fluorine is just F2. Just need to draw the outer shell. It tells us what the electron configuration is, 2,7. So that needs 1 more electron in order to fill its outer shell. So it will share that electron like that. So 1 electron in there and then 1 sharing back. So if there's 22 electrons in there, we need to fill the outer shell. So that's up to 8. And there's fluorine with just the outer shell electrons.